Yeah, FTD is firewall. Next generation firewall is FTD.
Oh, next
So
generation.
yeah, next generation firewall name is FTD. That is firepower threat defense device. So this device can do both tasks together. It can filter the layer 3, layer 4 traffic, and it can also filter layer 7, right? And you can say it can also filter traffic for URL as well, because Cisco have separate solution for URL filtering, which is WSA, Web Security Appliance, right? But FTD do the both tasks. Okay. Okay, let's start the class. Hope my screen visible to everyone.
Yes.
Okay, cool. Good evening, everyone. So this is our day 4, and we are starting with Cisco Appliance ASA. Okay.
Mm-hmm.
So the topic of the day is ASA. So ASA stand for Adaptive Security Appliance. So Adaptive Security Appliance is a Cisco first firewall device. Okay. So this is first firewall device of Cisco, right? And Cisco introduced this device in 2005. So I will write, which is introduced in 2005. Okay. Actually, this is not the Cisco actual firewall, because Cisco uh, acquired it from some organization whose is Pix. If you remember about Pix, right? So this is Cisco, not Cisco device. It's Pix device, but Cisco acquired it in 2005. Okay, so it can normally filter like which type of traffic it can filter: layer 3 and layer 4 traffic. Okay. And what I mean by layer 3 and layer 4 traffic, guys, any idea? So in layer 3, if I talk about layer 3, firewall can filter using the source IP address and destination IP address, right? Because at layer 3 we have source and destination IP address. And if we talk about layer 4, okay? So in layer 4 it can use the port numbers, source port and destination port number. Port number means like transport layer port numbers. I'm talking about the defined and random port numbers, right? I guess everyone knows from 0 to 65535, right? But this device can't filter at layer 7, right? So some after some time Cisco acquire another solution and they merge it with Cisco. So that other solution is Sourcefire, if you know about it. So Sourcefire is also part of Cisco now, part of Cisco from 2013. Yeah, it's from 2013. Okay, and after that, yeah, there is one more point. As we know, every device have its engine, or you can say like engine who can filter the such type of traffic like layer 3, layer 4, and layer 7. So the first firewall, which is from Pix, and the engine name is Lena. What is the engine name here? Engine name is Lena. So Lena is the engine name, or you can say heart of the firewall. Okay. So this is heart of firewall, right? Because every device needs something to process the things through it, right? So the engine name is Lena, and whenever they come up with a new solution, Sourcefire, so they try to merge it, and Sourcefire have some different engine. And what is the engine name here? Engine is I think it's Lena Sonode. Yeah, it's Sonode engine. Okay, so this is the engine name of Sourcefire, and Cisco tried to merge both of. Why? Because normal Lena engine can filter layer 3 and layer 4 traffic, but not the layer 7 traffic. So they acquire Fire device, which is also firewall, and that Sonot engine can filter layer 7 traffic. What is the advantage of Sonot? It can filter layer 7 traffic. So Cisco trying to achieve the goal to filter layer 3, layer 4, and layer 7 traffic together. So that is the main idea, right? To acquire. And now Cisco tried to merge the both firewalls together. So Cisco come up with a new series. That series name is Cisco 5500. Okay, so this is the Cisco ASA series who have both engines, the Sonot plus Lena. Okay, but this was a totally failure. This was totally failure because this didn't work. There was some challenges with this, so it was not working properly. So after some time, Cisco come up again with the same solution, but there was again a drawback. You can say they got the combination of both firewalls, like Sonod and Lena. Okay, but this time to access both the you can say both engines, to access both engines need to take separate GUI. So that means if I want to filter that traffic at layer 3 and layer 4, so I have to access Lena, right? Because Lena can filter at layer 3 and layer 4, right? To achieve this thing, I need to access the GUI of device. So this is my GUI number one to filter. To filter which traffic, guys? To filter layer 3 and layer 4,
Therefore,
right? And if I want to filter like for the same traffic which is coming from my LAN to WAN, maybe the source IP, destination IP, and port number I messed, but I have to mess at layer 7 also, maybe specific application, right? So to achieve that, I need to log in on Sonot engine, and I have to take another GUI, and I need to create another filtering policy for that, so I can filter layer 7 traffic here. Are you getting my point? So that means to achieve one task, you have to log in twice on a device. Are you getting my point? So one device have two engines, so you have to access separately, right? But if you talk about other vendor or other OEM at the same time, like if I'm giving you idea, because at the same time there were multiple vendors, right? Those were providing firewalls. So Palo Alto also providing good solutions, right?
yes,
So Palo Alto also have good firewall which have single graphical user interface to filter layer 3, layer 4, and layer 7
Layer
traffic.
7.
Is that clear? So that's why these are the some shortcoming with Cisco device. and this is your actually Cisco series. This is the series name. So now you will see you have here X with it, right? If you are talking about any series, but now these are I think out of support and out of sale, because if you buy any product like, so you are getting two things with it. Like I'm going to purchase this firewall. Okay, this is the Cisco ASA series. So whenever you are going to buy any firewall, so there is one point that is uh,
License.
yeah, license, right? So
Yeah.
whenever you are getting the license, so with every license, with every product, there are two things. That means one is sale, so for how long they are going to sell this product, right? And one is the support system that you are getting. So now I think both are end for this box anymore, because now they are not selling it, and even they are not supporting this device. Because like if sale is getting close in 2017, for an example, I need to check on Cisco side. That means they have sold this device last time in 2017. So after 2017, they stop selling it, right, to customer. Are you getting my point? So they stop selling it, but support system take long time, because if you sell your product in 2017 last, so around 2024 they are going to provide the support system, because after that time maybe customer will face any problem, any compatibility issue, or maybe some technical issue, right? So everyone is going to tag Cisco tag. So Cisco tag must support that product, because you purchased it and you got the license, right? So this is the I guess last year when they support for this. So after 2024, they are not going to help you with this product anymore if you will face any problem. So currently Cisco have one device that is in market. So that is FTD. That is FTD. So FTD is the latest firewall, okay, and that is firepower threat defense. Okay, so firepower threat defense. This is latest firewall of Cisco, which have multiple features, right? Like those features were not available with the traditional one. Like you have single GUI now, okay, and even this can filter at layer 3, layer 4, okay, and layer 7, and also provide URL filtering. Also provide guys URL filtering, right? But if you talk before FTD, there was another appliance that is WSA. So WSA is dedicated appliance to achieve this task. To achieve this task. Okay, so WSA we will discuss about WSA also, because this is also in the lab. So if you talk about there is a list on Cisco side. You will get the details like which appliance with which version they are going to be used in CCI lab. So you will check all the details there. Okay, you will go to CCI security lab equipments. So you will get what are the physical equipment Cisco is using in CCI security lab, and what are the virtual images with their version. Okay, so that is web security appliance. But we will discuss about all these things with time. Okay, I think this is clear. So that is history about Cisco firewall, like when Cisco started with the firewall. Okay, and when they enhanced the firewall, and what was the challenges with Cisco normal firewall, and then how Cisco come up with the latest firewall, that is Palo Alto. And sorry, my bad. Palo Alto is another vendor. So how they come up with FTD, and what FTD is giving you, like layer 3, layer 7 URL filtering, right? Okay. So now if these things are clear, we can start with normal ASA. Is that clear to everyone?
Yep.
Okay. So as we know, what is the use case of ASA? So let's start in deep. So this is adaptive security appliance, as we know, Cisco firewall. So normally, why we are using firewall? Can you explain, guys? Any one of you?
To protect the enterprise network from
Mm-hmm.
to protect the enterprise network from unauthorized users.
Right. So we want to protect the network from any type of
Unauthorized, unauthorized
right.
users.
Sorry.
From unauthorized users.
Yeah, from like from unauthorized user. Yeah, that is correct. But there are few more things that's why we are using the ASA. So ASA also giving us security level to prevent the internal user to access a malicious site, right? Like sometimes by mistake maybe user will access some malicious sites or malicious data, so that we can stop with the help of firewall, right? Because firewall give you multiple things, both type of security, from internal to external and external to internal. Okay, so we can say firewall is security device which is used to protect the network from any unauthorized access or data, right? So that means whenever any user trying to access the any type of unauthorized thing, so we can stop them, right? So that's why we are using the firewall. And how we are achieving these things on firewall? So we can define some type of policy. So using the policies, we can define who can access the outside network or not, right? So that is in our hand how we can do that. So we have policies. So in policies I can define this LAN user or this LAN subnet can access the internet or not, right? So those things we are achieving through the policy on a firewall device. Okay, for an example, we have here like this device. So this is ASA. So normally ASA is connected with the outside network, right? So this is your outside network, which can be internet, right? And ASA is also connected with inside network, that is our LAN network, right? So now we know LAN network is your trusted network, right? And WAN network is untrusted network. That means from outside anyone can try to hit on your network. So that's why we need this security appliance who will allow, according to the policies, like you are permitted to come inside the network or you are not permitted to come in the network, right? So that is all because of policies. So in policies we can specify the user network and give the permission and deny commands, right? So that is the main role of a security appliance in the network. Like there are more things that we will discuss with time. Okay, so these are the basics things about Cisco ASA. Is that clear, guys?
Yes, sir.
Okay. Now in ASA, normally we will start ASA with CLI access, right? So as I told you, we have CLI access of ASA where we can configure the device. Okay. So first of all, we will discuss about ASA, how to access the appliance. Then we will discuss about the normal packet flow of it, right? So how we can access it? So we have to access the device through CLI. So we have direct console of the firewall. right? Then we can access it with through telnet, or we can access it through ssh. So these are the media that we can use to access any security appliance. So first of all, we will start with the console access of the firewall. Okay, so in that we will see the CLI context is little different from normal firewall, and how we can enable talent and assets, that is also little bit different from a router. Okay, because this is security appliance, so maybe the commands are a bit different. You need to enable another commands as well. Okay, and you need to allow talent access on the device, right? So let's start first of all with installation. So if you have laptop, everyone. So first of all, you can install the VMware workstation. I shared it with team. I guess you all received it, right? And some temporary key also that you can use to provide as a license key for the software. Okay. And later on, what you have to do, you can install EVNG or you can install Peanut Lab. So I prefer Peanut Lab because in Peanut Lab we have some features that is with Eve Professional, because Eve Professional is a purchased solution, and Peanut Lab gives those features even without license. Okay, that is the one difference. And to download it, you can go to the internet and use Peanut Lab. Okay, and you will get Peanut Lab simple and download this one. Okay, so here are the steps, so you can follow, and you can download it from anywhere, right? And after that, if you want to upgrade the package, like current version is 4.2.10, right? So this is the current version of the Peanut Lab, but maybe mine is 5 point something. So you have to go to the releases. Okay, so here are some patches, so you can download this patch, and those commands you have to run. Okay, you have to follow the steps, and after that you can do. So I will share some YouTube videos of mine, so those you can check how to install the Peanut and how to upgrade it. Okay, and after that there is one link that is just go on lab hub. Okay, so lab hub is URL where you can get any type of image for EVNG and Peanut for both. Okay, move to the add-ons. Here you will get IOL images for normal layer 2 router and switch, so you can download these images. Okay, and even you can go for QME. So QME have other images like firewall, Cisco SD-WAN, all type of image, but we are talking about Cisco ASA. And which image we can use? Wait a minute, I need to check. Cisco security appliance list. So this is the equipments list of CCI. We can use 9.4. That is the virtual ASA. Okay. So this is the virtual ASA 9.43. Okay. 9.4, right? Yeah, it's 4. So wait a minute. 9.4. But I guess this is the not exact one. Let me check here also. Cisco SA. Yeah, here is the ASAV. Okay, and I will try this one. Just a minute. Wait a minute. It will take some time. Okay, guys. So let's wait until it's going to download. Okay, so until that we can power on the virtual machine. Okay, and one more thing, before that, after installation of this, you need to move into the processor and make sure this feature is enabled. If this is not enabled, virtual intel vt -x, so your asa image will not run right on device. So you need to make sure this is enabled and power on it. Okay,
Sir, I didn't get any VM details.
sorry.
I didn't get any VM details, sir.
Okay, you have not get. Actually, these are free. I will share with you where you
Okay.
can download it. Okay, I will share the links in chat on WhatsApp. Let me access. It's 130, 129. Yeah. Okay, this is the IP address. Now, okay. And now if you click on the nodes, okay, like there are multiple options like add object and nodes. So right click nodes. So it will show which appliance are downloaded. So show unsupported. Okay. I guess all the images are downloaded on my device. Yeah, all images are already downloaded, I guess. So I have ASAV, which is 962 version. Okay, so I can use this device as appliance, and yeah, just save it. Okay, so here is the image. So after download, how you can upload the image? The process is very simple. So you need here one software that is available on internet. You can download it. And wait a minute, what is the name? That is WinSCP. Yeah, so WinSCP is the software you can use, and you need to use IP address of the evnz or pnet. After that, it will ask about username. So username is root if you are using, if password is ev in small. If you are using pnet, the password is pnet. Okay, in small. Login it. Wait a minute, what is upgrades? Okay, so just click here and move to the opt and unit lab add-ons. So here we have qme, right? So these images are already installed. So you have to download the image, and after that you have to just copy and paste here, right? Like if you have any image here, for an example, right now I don't have any image. Yeah, like this one, right? So you can just click and put it here like this. Okay, okay. And after that, if you are using evng, you need to run one command that is available on internet: fix permission command. Okay, so if you check, this is the fix permission command you need to run on CLI of evng. If you are using pnet, then it's not required. Okay, so we have this to router. Let me delete it. Okay, so how we can start the asa? Start the asa, and I can connect it with my management network so I can access it. Okay, so asa have multiple interfaces. If you check, you are trying to connect, here is the gig 0 by 0 interface, and it also have management port. So I'm using the management port so I can access it on my laptop. Okay, with my management network. This is the management network. So just click on the device, and you can see the device is in boot process. Uh, Wait a minute. Wait for a minute. So first of all, we will see how to enable telnet on the firewall and then how to enable SSH. Okay. So the concept is a little bit different comparison comparing normal devices. So let it boot first, then we will see. A minute. Okay. Let me start it also because I need to check this firewall is working or not because it's giving me same output again. Maybe the image have some issue. Okay, now we're good to go. So I'm starting with the first ASA, which is virtual ASA. This one, this is in the lab. Okay. So virtual ASA have separate management port as you are able to see. But if you talk about this firewall and if you try to connect it again, so it have normal Ethernet ports. Okay, like a physical firewall. But virtual have management port separately to access it. Now let's start with the normal configuration. So this is the default hostname, and when you are trying to put enable command, so firewall is asking about the password, but by default there is no password. So what you have to do, just press enter, nothing else. Okay. So this is security appliance. That's why it's showing you to enter a password, but password is not required here. Just enter it. Okay. The command is similar configuration terminal. Okay. Before that, if you want to check show version, we can check the version of the firewall. So we are using 9.6 image. Okay. And now these are the hardware details, like this is the version, this is RAM and CPU. Okay, CPU Exxon, and the series, and the model ID is ASAV10, right? And it have one management interface, and these are the uh, data interfaces with their MAC address. Okay, virtual MAC address. And the device have some default license. If you check like what feature we can do, we can use maximum 10 interfaces. Okay, 5 VLANs. These are the unlimited host, like how many LAN user can be there, and it have failover feature. Failover feature means if you talk about like normal ASA can do multiple features, or we can enable multiple features on on Cisco ASA. So the first of all, Cisco ASA can filter the traffic, right? The filtering we are getting on firewall. Second, firewall is also providing a net policies, so we can use netting on Cisco firewall, right? We can use static net, dynamic net, right? PAT, static PAT, these features. And if you talk about VPN, Cisco firewall is also giving you VPN option, like we can use site to site VPN. Okay, we can use client VPN. If you remember, on laptop you have one software which you can enable that automatically create your VPN connection with Cisco firewall, which is AnyConnect, right? Client VPN. And you can use DMVPN is also, that is also VPN with using IPsec. Okay, and it have private VPN also that we will discuss in upcoming classes. Okay, so it support multiple type of VPNs. After VPN on firewall, we are also eligible to use at a layer 3 device to enable the routing. Okay, that is layer 3 device. We can enable routing, we can use OSP or TCP. But in some cases, if you don't want to use Cisco firewall as a layer 3 device, what you can do, you can configure it as a transparent mode. Transparent mode is like a layer 2 mode, okay, or layer 2 device. So that is known as bridge mode, right? Guys, you know about bridge mode, like bridge is a layer 2 term. If I talk about switch use spanning tree. So normally we talk in spanning tree about bridge ID, right? So bridge is the first layer to switch. Okay, then they enhance the bridge, okay, using some additional ASIC chip and other uh, hardware resources. So they make name from bridge to switch. So bridge is layer 2 technology, so we can configure this firewall as a layer 2 device. Okay, just a minute, I think I need to stop one ASA. The firewall is consuming more. Okay, okay, so what else we can enable on a firewall? Um,
The port number?
Sorry.
The port number?
Yeah, maybe laptop is misbehaving. Okay, so one is the transparent mode. After that, do you know about high availability, guys? What is high availability?
Yeah, the firewalls will keep in redundancy.
Right. So, like if I'm using a big infra, so I always make sure my devices must support high availability, right? So, high availability features also exist on Cisco Firewall. The one is known as uh, failover and clustering, right? So that feature we are achieving with firewall. So I can use two ASA and I will get failover and also clustering, like active standby or active, right? Okay.
Uh-huh.
So I can active and standby solution, or I can use active also in clustering. So these options we are receiving. Okay. So we are receiving multiple things in single ASA. So first of all, we will start with normal configuration, how we can configure the device, how we can use the management of the device. Okay. So, okay, so that these are the license that is about failover. Failover means firewall can use active and standby. Okay, and you can use the encryption, which encryptions are supported on the firewall. And the one thing is here security context. What is security context, guys? So security context is also feature. Maybe this version is not supporting. Maybe I need to use a physical ASA like this ASA, which we stopped right now. So security context is your virtual firewall. Like using security context, I can use one firewall as a two firewall. So virtually, I am dividing a firewall using this feature. So that is also available with Cisco ASA, right? Okay. Just a minute. It's misbehaving. I need to close some applications. Uh, okay. So now we have access of the firewall. So the first command, if you want to check the interface, so show IP interface brief command is not working here. So what we need to do, we need to use this command show interface IP brief. So that is a bit opposite. So you have to use interface first and IP later, right? So there are few differences, right? And you can check we have these are the 7 gig interfaces and one is the management interface. So first of all, what we have to do, we need to configure the management interface. Okay, and I'm going on the interface management 0 by 0. So no shut down the interface, and you can give IP address like I'm using this subnet 168.130. So I can give 51 IP here, and subnet mask is this, right? Okay. So if you want to check now, is this IP address available on the interface or not? So what I can do, show interface IP brief. Yeah, interface IP is visible here. So that means normally if we provide IP on any interface, so that IP also visible in the routing table also, right? So how we can check, guys? So we need to check with this command show route, not show IP route. Show IP route command is working on Cisco iOS, but on Cisco ASA we need to use show route command. Okay, and you can check still routing table is not like routing table is empty. Why? Because management port is using separate routing table for it. Show route management only. You have to check routing table which is for management network, right? Because normal routing table don't contain the management networks in it, but still management routing table don't have your route. So that means you are not able to reach it. If I try to, let me try. The IP address is 51 ping 192.168.130 and 51, right? So you can see the IP is not reachable. Why? There is one thing that is required on the interface. And what is that? Okay, show run interface management 0 by 0. So you can check, there is one thing that is known as name if. So on Cisco ASA, we need to give name to every interface, because using the name we are going to attach this interface in such policy, such net rule, right? So that's why this is mandatory. So if you don't give the name, okay, so it will not visible even in the routing table, right? So that is the reason. What name we can give, we have multiple type of names, okay, according to the interface. But for right now I'm just going for management interface 0 by 0. So you can give any name if mgmt, okay. So whenever you going to assign the name, automatically device will give a security level to your interface. So what is the security level now? Like name if is new thing, security level is also something new. So just wait for few minutes. We will come on that point also. What is name if? What is security level? Okay. When we will start with the normal traffic on Cisco ASA. But for now, just make sure we need to give it the name, and I can verify my configuration. Yeah. So name if is management, and when I put this name, automatically firewall is giving a security level 0. So security level is from 0 to 100. So 0 is not trustworthy, or you can say 0 have less priority, and most preferred is 100. Okay. And even we can check route this time for management network. Still route is not available here. Why? Am I able to ping device? Yeah, I'm able to ping. Maybe because of management the route is not visible here, but I can ping this one, right? So this is the one thing. The second point is now how I can take the console of the device. So let me give host name first of all. So this is ASA1, okay, for me. Now name is configured. And how I can enable telnet? So there I need to give first of all username. Username is admin. I can give privilege level similar like that, and password. Wait a minute. Is it giving me option of password? Why? Okay. Privilege level I can give like this. And in the same command, I need to separately configure the password. So username admin have privilege level 15, and also password Cisco. So these are two different command, not with single user. Okay. Sorry, not with single command, but the point is same. In Cisco iOS, we use username admin privilege 15 password Cisco. But I do the same thing with twice. And next thing, by default, AAA is enabled on Cisco ASA. So in AAA, you need to allow the authentication, login. Okay. Wait a minute. What is the command? Authentication, telnet, console. Wait a minute. I need to give here local. That must be in capital, guys. Okay. So this must be in capital. Don't use the small. Okay. And after that, I can say, okay, I want to telnet. So that how you can enable your telnet. So on normal router, we use line VTY, right? Under line VTY, we enable it. But here I need to enable it like this. Telnet, I can give a single host IP. I can give the complete network. Like I can give like this. If I want to allow everyone, every subnet to take telnet of my router from management interface. So see, here I am using the name of the management interface. Okay, so that means any network device can take access of the firewall from this management interface. So if you check, this is the name. So they are asking about the name of the management interface, right? Just we put that. So I did the entry, so no need to put it twice. Or you can do one thing, clear configuration, telnet. Wait a minute. Yeah, it's not working. Clear configuration session. telnet. Telnet session is not working. The command is not working here, but why? Clear configure telnet. Okay, so this is the command. Okay, so that how you can clear the configuration of telnet. So the easiest way is this 0 0 So that means I defined any IP with any subnet mask can access the device through telnet. Okay, and we defined the username and the password. Now let me try with putty. 192 168 130 51. I guess Telnet have one problem, that is security level. So security level must be 100 on that interface. Even not sure this is going to work with management, but let me try. So I can give security level 100, okay, and we can try again. Yeah, you can see. So there is requirement for telnet. So if you want to access the telnet, so telnet is only allowed with security level 100. Okay. When security level is 100. So that means if you try to access that telnet of firewall, so one thing, telnet is not secure. Still you are trying to access it through telnet, and telnet firewall make sure telnet connection established with interface which have security level 100. So management interface I can't do that, right? On MGMT interface we don't use security level 100. So what? So need to take through LAN interface. So on firewall, LAN interface have security level 100. So I can access the firewall through my interface, not through the management interface. Okay. So that is the one requirement. So now we have here access. I can use username password and see I'm getting here access, right? So not this command. So you can use here this command, I guess. Yeah. So with this command, you can see who have access of your device. So this IP address have access of your device. Okay. And if you want to do that, like kill, you can kill the session. Okay. So now I lost connection, right? So that how we can enable talent connection. Is that clear to everyone, guys? Kenel, Siva, Nandita,
Yes.
guys.
Yes.
I guess this is very simple, right? Like the command line is different in this case because we are talking about a security appliance. Okay, Sankar, is that clear to everyone?
Yes, sir.
Okay, let's waste here time because we need to discuss a lot of things. And the second is SSH. How we can enable SSH? So without even security 100, I guess we can access the SSH through any one of the interface. Okay. So similar AAA is enabled, but for telnet, and user is already configured, right? So I can move to AAA. Uh, Authentication, and here is SSH console local. I configured this. I need to use this command SSH. Similar, I can configure same thing here also, like host, IP, whatever I want to configure. Like I want to configure this one right now. Dot one. Okay. If this is single IP, I no need to configure. I can, okay. Do I need to configure? Or host command is available here? No, host command is not available. I need to configure. So single IP is with slash 32, I guess. If something is wrong, we can check from management interface. Okay. Now I can try. 68, 130, 51. Yes, I want to make connection. Yeah, server host is not in cache register admin. Password is Cisco. Yeah, so here we have. Okay. So we have accessed the device, and if you want to check again, who is this? Wait, wait, it's not visible here because of SSH. Yeah, maybe we say because of SSH. Okay, but if you want to do that, yeah, it's SSH connection is not visible because of the secure, so that's why. But this is the minimum configuration which we can use for telnet and SSH. Clear, guys?
Mm-hmm.
And one more thing, if you remember, I have not enabled any crypto key in the case of SSH here. Why? Because this is virtual ASA, so it will give you. But if you talk about the physical firewall, okay, because right now we are using FTP, but I'm talking about from ASA point of view, crypto key generate RSA. So I will give suppose my key. Wait a minute, what's wrong now? Label. I need to give label, and label is my key. The name The name for the key will be my pub key. Okay. Key pair generate process begin. Please wait. Okay. Let's wait for a few seconds. And show crypto my pub key RSA. So we have here one is the default key, default RSA key. Okay. The second one is key. Now there is one problem in physical hardware. So if you create any key with your name and you are trying to access with SSH. So wait a minute, can I copy my key? Okay, yeah, I can copy my key. Keychain. Wait a minute. Keychain configure mode command option. What is this? I want to give the name of the key. Oh, mode copy. No. Let me try again to access it through SSH. So let me make a duplicate session. Yeah, still I'm getting the access. But in the case of physical ASA, if you are going to create your own key, this will not work because ASA work only with the default key. Okay, if you are using default key, at that time only you can take SSH of the file. If you will create your own key, it will not give you access. So this is the challenge with the physical box. Okay, so you have to make sure about it. But I'm trying to check the command where I can find my key. Host key exchange configuration my pub kitchen. Let me try to copy here if it's possible. No invalid hostname. Configure mode commands. Timeouts key exchange. Okay, it's about Diffie Hellman. Maybe the command is not available. Just I was trying to bind my manual key with this. Okay. But even you have to take care. You have to use the default key to take the access of the firewall. Okay. If you will face any problem, that is the only one reason. Is that clear, guys? Okay. So that how we can access the management of any firewall through telnet and SSH. So later on we will discuss about ASDM access node right now, or the next generation firewall. So now I'm starting with the basic packet flow or how ASA is working, right? So ASA use stateful packet inspection. So what is stateful packet inspections that we will discuss, okay? Like the behavior of the ASA whenever traffic is forwarded by the user. So this is the user, just a minute. Okay. So here we have Cisco ASA connected with internet, right? So every interface have here name in Cisco ASA. So whenever we are going to configure, I will configure like for an example, this is my inside interface. So I'm going to configure inside, and here this is my name is outside, right? And then we give the name accordingly. Device provide the security level to the interface. So first of all, we need to define the name if on the interface. So name if is name of interface, okay? And if we configure, if we use inside name on LAN interface, then automatically firewall give security level 100 to that interface. That means if I'm using here in inside name LAN interface, so automatically firewall assign security level 100 on LAN interface. So this is the by default, okay? So if this is my inside, so automatically inside will get 100 security level, okay? And the security level for other interface, if you configure anything else instead of inside, okay? If configure anything else, okay, instead of inside, firewall assign security level 0. So that means if I configure any other name instead of inside, then automatically firewall give security level 0. So outside interface will get which security level, guys? It will get security level 0. So according to security level concept, firewall is talking about the security, trust level. So which is more trusted interface, which have 100 security level, and which is lower trusted interface, which have security level 0. So ASA always working on concept of security level, and accordingly by default permit the traffic. Okay, so that means security level 0 have lower priority. Okay, so this interface talk about low priority. That means if an interface has security level 2, this is not that much trustworthy, less trustworthy. Okay, less trustworthy. And security level 100 is with highest trustworthy. Okay, so now the range of the security level is 100, 0 to 100. So this is the range of security level. That means if I want to assign on multiple interfaces, so accordingly I can configure. So if I have firewall and I want to configure security levels, so suppose this is the firewall. Okay, and on this firewall I have four interface: one, two, three, and four. So every interface I'm going to configure, like this is LAN, this is with 100 security level, this is with 70, this is with 40. Okay, and this is with 30. So I need to configure security level on each interface, guys. I guess this is clear to everyone, right? But now there is one point that we have to make sure. And what is that? So you need to make sure about that. Same name if count configure on multiple interfaces. Okay, so that means I can't use same name on multiple interfaces. So ASA will not allow that. Okay, but same security level is allowed to configure. Okay, so we can use same security level on multiple interfaces or on same interfaces. Okay, so that is possible, but there is restriction. And what is that? Same security level interface can't communicate by default. So by default, same security level interface cannot communicate with each other. So there is problem. So there are some commands that we can use. So after that, maybe communication is possible. But by default, if you don't do anything and you give same security level, they can't communicate. Okay. So I think these things are clear. So just we talk about here what is name. We can give any name to interface. So if you give any name instead of inside, so every interface will assign itself as a security level 0, right? But manually we can change the security level on interface. So under the interface we can put this command security level and level number, right? So higher security level is here trustworthy, which is 100, the max. Okay, and the minimum is 0, which is less trustworthy. So now how firewall is working according to that? Like if I have given here security level 100 and 0, so how firewall is going to work? Like if this user 10.1.1.1 is the IP address, and here is 10.1.1.10 gateway, and this is the public IP 101.10, and here we have 101.1, right? This is the IP gateway. So how this user is able to communicate with outside network? So how firewall is receiving the traffic, and what firewall is going to look for that? So if these things are clear about name if and security level, so according to security level, how firewall is doing this, we can talk about that. Guys, till now, do you have any doubt? Okay, so this is our inside and outside, and the security level is 100 and 0. So by default, Cisco ASA by default means like which is given with the device. The feature is given with the device. Okay. So Cisco ASA allow traffic higher level to lower higher security level. Okay, that make it complete. Higher security level to lower security level. That means if anyone is trying to send data from higher security level 100 to security level 0, that traffic is permitted. That traffic is permitted. Why? Because you are sending traffic from inside to outside network, right? You are sending traffic from inside to outside traffic. Okay, and that traffic is known as outbound traffic, right? Outbound means which is sending to outside network. Okay, but lower security level to higher security level is not allowed. So that means if any user is trying to send data through firewall and that is coming on a lower security level, so firewall will not send on a higher security level. So that is not allowed. That will be denied. Is that clear?
Yep.
Okay, so now let's understand the packet flow. So here I'm starting with the packet flow. Like if user is sending data, what ASC is going to check first, and how it will check I have to forward to this interface or not, right? Okay, so we have here IP address 10.1. Here is 12.10. Okay. Now here we have 10.1.1.10 and 12.1.1.1. Okay, these are the such IP addresses. Now device is trying to send some packet. Maybe the user is trying to take telnet of that router, right? So maybe this is the first TCP packet, that is synchronization packet. If you remember, if there is any TCP protocol who is start communicating, so first of all there will be three-way handshake. So user is sending sync packet with 10.10.1 IP address to 12.1.1.10, right? The server, and the source port is like your random port number and destination port number is 23. Why? Because this is TCP based protocol, Telnet. So Telnet have port number 23 for synchronization packet also. So whenever traffic is receiving on this interface, so what is the first thing that is firewall is going to look up? So first of all, firewall is going to check routing table, right? So now it's going to check routing table. The route is belong to 12 network. So 12 network is configured on outside interface, right? So after checking the routing table, router is going to check, okay, I will get the exit interface. So using routing table, what router is getting? Like what is the exit interface? So according to exit interface, router have to check security
Level.
level policy. What is security level policy? Okay, so every interface have security level policy according to their security level number. So like just for an example, let me give you this example first, maybe then you can relate my point. So we have four interfaces like this. Okay, again. So this is the 100 security level, 60, 40, and just assume this is the lowest one, 0. Okay, so that means, as we know, whenever traffic is coming on this higher interface, okay, so this higher interface is allowed to send data to this interface also, right? Allowed to send to this also, to this also. Why? Because we know traffic is allowed from higher to lower, right? So those interfaces have LSP, this one, this one, this one, but not this one, because this is the lowest one, right? Then no need to check security level. So every interface have security level policy, security level policy. So, or I can say SLP. Is that clear to everyone? SLP, security level policy. So this interface is receiving traffic, and after the routing table lookup, after the routing table lookup, firewall get to know, okay, I need to send data on this interface, on 60 interface. So router check, this is my exit interface. I'm sending data from higher to lower, so that means my traffic is allowed. My traffic is allowed, right? And similar, if 100 is sending data to this 40 also, so this is also from higher to lower. So LSP, sorry, yeah, SLP allowed this traffic, right? SLP allowed this traffic, and similar in the case of 0 also, this will allow. But if I talk about traffic is trying to send from lower to higher, guys. Traffic is trying to send from lower to higher. So this is the lower here, right? 0. So traffic is trying to come on that interface. So firewall is going to check first of all routing table, and maybe exit interface is your 40, this interface, right? So whenever this firewall is trying to send data, so there is no SLP actually, because this is the lowest one. If there is no SLP, this interface can't drop the data. So data will come to the engine of the firewall, and firewall have some default policies. They are going to deny the traffic. They are going to deny traffic. Why? Because traffic can't forward to higher level. But if they don't have SLP, okay. But for an example, this interface have, okay. Let me repeat my point. Maybe there can be some confusion. Okay. Now here is some global policy on the firewall. That is, global policy is like this: deny any. Are you getting my point? So this is my default policy, you can say, on firewall. So if traffic is coming on lowest security level interface, okay, so first thing, this interface don't have SLP. So according to SLP, this interface can't drop the packet on interface level. So traffic must hand over to the device, to ASA, right? Like ASA will receive the traffic, or you can say the engine is receiving the traffic this time. So this engine have default policy, that is deny IP any. Deny IP any. So here traffic is going to drop on the CPU of the device if interface don't have SLP, and which interface don't have SLP by default, which have lower security level, like this have 100, this have secure 60, and this one have 40. So this is the only one interface which is the lowest security level. So this interface don't have any SLP. So that's why traffic is going to the CPU of the firewall, and which have default policies deny IP any. So at that level, firewall is going to drop the data. Are you getting my point, guys? Everyone?
Yes, sir.
Okay. So this is the first point which I discussed about lowest security level interface, right? So the second point is if we have like security level 40, which have SLP, right? And data is moving to this interface, which is with 60 security level. So in that case, if traffic is coming on firewall and on in this interface, or sorry, the firewall is going to check, okay, traffic is receiving on my this interface. It can have, maybe I have any name. So first of all, firewall is going to check routing table, and routing table is giving you idea about the exit interface always. Because if you check routing table, so route have always exit interface like gig 0 by 1. This is your exit interface to reach this network, right? And now traffic is going to check after this security level policy. So policy says on this interface you have security levels 40 and other interface have 60. So at this interface it will drop the data. So traffic is not required to send to this CPU. So CPU is only check in the case of, or you can say the global policy, not this, not mention it with CPU. Just say it global policy. Okay, let's say it global policy. So this is global policy. So global policy is checked when interface don't have SLP. If interface SLP, firewall drop the traffic on interface level directly. After checking, traffic is coming from lower and trying to move to the higher security level. So if these 2 points are clear, I will come back to my this diagram. If still have doubt, please let me know. I will explain the same thing again. Everyone, Kenel, Siva, Nandita, Sankar,
Yes.
Yes, yes,
is that
yes.
clear? Okay. It's nothing like security on every interface, and lowest one don't have security. So traffic is moving to the mother. Mother is global policy, right? Okay. Now in this diagram, user is sending traffic to the ASA and interface is receiving the traffic. So as I said, first of all, firewall is going to check routing table. After routing table, firewall is getting the exit interface, which is the exit interface. So exit interface is this one, like it's 0 by 1 and this is it's 0 by 0. So exit interface is it's 0 by 1, right? And now if it's 0 by 1 is exit interface, so firewall know, okay, so I'm moving the traffic, okay, from 100 security level to 0. So according to my SLP, what I need to do? Allow it. What I need to do? Allow the traffic, right? Is that clear? So that means traffic will pass the firewall and traffic will move to this server. So whenever server will try to send back data, so this time traffic is receiving on which interface, guys? Which interface? Lower security level. So this is lower security level. So whenever it's going to check the routing table, it's going to check the routing table. It will get the exit interface. Exit interface is it's 0 by 0. But firewall check, this is from 0 to 100. And 0 to 100 will deny. So firewall check and send data to global policy, and global policy is going to deny it. Are you getting my point? So what we need to do here? what i what I explained to you guys, this is very simple. We have ASA, right? This is the ASA. Here is the LAN interface, WAN interface. Outside, inside. Okay, you need to understand this point, otherwise you will not understand the concept of ASA, how traffic is forwarding through it, right? Security level 100, it's 0 by 0. Security level 0, it's 0 by 1. IP address 10.10, IP 12.10. Here we have 10.1, say 12.1. Okay. Now, user try to send data. So the first thing, firewall is going to check routing table for destination. Source is 10.1, destination is 12.1, right? Okay, and then we have port number, source port number, and destination port number. Okay, so first it's going to check routing table. Routing table is giving you idea about exit interface. Okay, so exit interface is which one, guys? It's 0 by 1 is exit interface. So according to that, the traffic is moving from higher to lower. So that means traffic is from 100 to 0, and that must be allowed. Is that clear? So traffic is allowed and forwarded to the user, the destination user. So now destination user is trying to send back data to firewall. So firewall is receiving data on this interface, and firewall going to check routing table, exit interface times 0 by 0. So traffic is receiving on lower security level and trying to move higher security level. But this interface don't have TLP. So this interface is going to hand over the traffic to global policy. And what is the global policy, guys? Global policy is deny IP, any, and
Hello?
traffic will, yeah,
Ok.
traffic will drop.
Ouais. Dis-moi si sorry, mais ça passe, c'est pas photo.
Uh, Kanal, are you asking something? Hello,
Ouais.
Kanal, are you with us? Hello, Kanal.
Yes, I'm here.
Okay, I thought you were asking something, or you were with.
No. Yeah, just answer someone else. Thank you so much.
Okay. But now, guys, there is one question that you can ask. So, for every traffic, if firewall, yeah, the point is valid. Like we are able to forward normal traffic to outside network. So, because this is the concept of Cisco firewall, right? But whenever we are looking for same traffic to receive back, the traffic is dropped. This is not something good. Why? We forwarded the traffic and we want to receive back it, right, as a response. Because this traffic is not initiated from outside network. This is not initiated from outside. So inside user is initiating the telnet connection with some outside server. So this server is sending response back to firewall. So there must be some mechanism on firewall who will check this is the response of my traffic which already passed through me from LAN to WAN. So I must accept it. I must accept it. So the first rule, if ASA is not checking that, I need to check or I need to apply here some policy on WAN interface. If this is the traffic, you must accept it. For every type of traffic, we can't apply the policy. So that's why Cisco ASA is doing stateful packet inspection. What Cisco ASA is doing?
Stateful bucket inspection.
Yeah. What is stateful packet inspection? Stateful packet inspection means if any traffic is passing through ASA from LAN to WAN. Okay. Understand this line? If any traffic is passing through Cisco ASA from WAN to WAN network. Okay. ASA is creating a connection table for same traffic. Okay, like Cisco AS is inspecting the traffic and creating the entry in your connection table. So that means if I forwarded some packet to Cisco firewall inspect that traffic with inspection engine, okay, and then create entry in my connection table, okay, and this connection table is checked for return traffic by firewall. Are you getting my point? That means which traffic I forwarded through ASA, so that is also receiving back, right, as a response. So if I send SYN packet to server, server must send SYN plus acknowledgement. So that acknowledgement packet passed through ASA from WAN to LAN network using the connection table. Using the connection table. So by default, Cisco firewall inspect this type of traffic. Which traffic, guys? Let me write down. ASA inspects the TCP and UDP traffic by default, but not the IP traffic. By default, Cisco ASA inspect the TCP and UDP traffic, not the IP traffic. Okay, let's rediscuss the same thing which we discussed above this point. Okay, uh, everyone, these 2 points clear or not? If these are clear, let's discuss about them. How ASA is working now after this inspection feature. Everyone,
Yes, sir.
okay. Is this interesting topic or I hope everyone is with me. Siva, Kenel.
Yes, 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 yes.
Guys, are you getting my points or not? Like, I want to understand. If you are not able to understand, you can just tell me. I will repeat the point. Maybe I will try to explain bit more about it. Okay, but the point is, you need to understand this is the basic of ASA. From here, you will understand how ASA is working actually, because this is the basic packet flow without any policy, without NAT or without VPN. Because once we start understanding the packet flow, if I'm going to add any feature in future, like later on I will introduce policies in ASA, right? So if I will add policies, then I will increase one more step in packet flow, right? And later on with policy, maybe I'm talking about NAT on ASA. So that will increase two more steps on ASA, policy and NAT, right? So we have two type of nets. So you will understand all the points one by one. So that is my idea. So still, if you have any challenge, just let me know. I will try to repeat the things so you can understand or you can get. Or is it, or are you done for the day, guys?
No, sir, it is interesting.
Okay. So let's understand this first, okay? Because tomorrow I will start with the actual configuration on ASA LAN WAN IP, okay? And we can see the connection table, the trees, okay? And if any traffic is not inspecting on ASA, we will check how we can make manual inspection for some traffic, okay? So let understand these 2 points first, okay? Before moving. So right now, what I'm saying, ASA is using stateful inspection engine. Stateful inspection engine means if this is the Cisco firewall, ASA. Here we have some server, and here is the LAN user. 10.1, 10.10, 12.10, 12.1, right? And this is it 0 by 0, it 0 by 1, and this is our inside interface with security level 100, outside interface with security level 0. Okay. Now the user is okay. By default, Cisco ASA is inspecting TCP and UDP traffic. Make sure not the IP traffic. Okay. So in that case, what is the actual packet flow now? So the user is sending synchronization packet, random source port number, destination is 23 if I'm using telnet, source IP is 10.1, destination IP is 12.1, right? So this is my packet. I'm not talking about the detailed information in packet like and all. Okay, those are CCNA things. So traffic is receiving on router, sorry, firewall. So now, what is the actual packet flow, guys? Could you tell me? Let me add one more point. First of all, Cisco firewall check the connection table. What it's going to check first of all, guys? Connection table. Connection table means when traffic is receiving on this interface, ASA check is there any existing connection for this data or not. So connection table created on the basis of these parameter. What are the parameter, guys? It check the IP address for connection table. What is the IP address? Okay, source and destination. It check the protocol, what protocol they are using, and it check the port number. So these are the three things that is exist in our packet: port number, IP. This is TCP based packet, right? So using these things, ASA create a new connection. Okay, so the first traffic is receiving on this interface. So ASA check the connection table. If there is no entry, okay, or you can say if traffic is receiving for the first time, there is no entry. So there will be no entry in connection table. But if your traffic is already passed through the ASA, there must be connection table. Okay, or traffic will pass through that connection table. But this is the first time whenever there is no entry in the connection table. So it will check the second step. So second step is routing table. What it will check? It will check the routing table because connection table is empty and there is no entry. So ASA check the routing table, and routing table is giving you idea about the exit interface, right? So exit interface is it's 0 by 1. Okay, so you are sending data from 0 by 0 to it's 0 by 1. So accordingly, now firewall check the security level policy. Firewall check the SLP, and SLP says you are sending data from higher security level to lower security level 100 to 0. So that means traffic is allowed. So once traffic is receiving on this interface, after this all inspection, ASA maintain the connection table. So this is count table. Okay, the count table name is available on CLI on ASA. So it creates the entry like this user send data to this user using port number. They also have port number like this. I guess I need to check that database. 10.1 port number is like this, destination is 12.1, port number 23. Okay, so this is allowed. Okay, and this is TCP based data. So entry is created and traffic is allowed. That means traffic is now moved to physical interface and it will send data to your device. So traffic is passed, now entry is created by the firewall. So when traffic is returning from server to device, so traffic will come on the each 0 by 1 interface. So each 0 by 1 interface, first of all going to check connection table. First of all going to check connection table. So connection table have entry for the written traffic. So you no need to do anything. Traffic will inspect already inspected, and correction table have entry, so traffic will allowed from WAN to LAN, because this is initiated by LAN user moving to WAN, and WAN is giving reply is your SYN plus acknowledgement, right? Like source port number is 23, destination is this one, for public IP is 12.1, and this is 10.1, and protocol is TCP base. So this have entry in connection table. This is the entry if you check. Okay. So according to this entry, traffic will forward to ASA, and ASA will directly put outside from this interface to the LAN host. So that how traffic is moving from LAN to WAN. And these are the normal steps. So these are the basic steps right now we are talking about, like connection table, routing table, SLP, and then allow or deny the traffic accordingly to SLP. This point is clear to everyone. Guys,
Yes, sir.
Yes, sir.
okay.
Mm-hmm.
So here I'm talking about TCP and UDP traffic, not about the IP traffic, not about the IP traffic. So can anyone tell me about if I'm using IP traffic, maybe I'm using ping. I want to try to ping from 10.1 to 12.1. What will happen? What will be my packet flow, and where my traffic will drop and why? You already know that. If I will explain, you will get. Okay, we already know that. Okay, let me explain you. Okay, so in this diagram, we have here security level. Okay, so this is only going to inspect the TCP and UDP, not the IP. Okay, so whenever traffic is coming from this user, so this is ICMP data 10.1, trying to ping to 12.1, right, through ICMP. So when traffic is coming on ASA is going to check first of all connection table. There is no entry, so it's going to check routing table. Routing table is giving you idea about the exit interface 0 by 1. Okay, and now firewall check the SLP. From SLP is from 100 to 0. So whenever traffic is passing through ASA also maintain entry of ICMP in connection table. ICMP entry into connection table. So it will assign like 10.1 port number 0, 12.1 port number 0. Okay, like this, and traffic is ICMP. So ASA maintain entry for IP traffic also. But once traffic is reached to end user, here traffic will revert, right, as like ICMP reply. So whenever traffic is receiving on this interface, ASA will not perform inspection for IP data. Why? Because ASA create entry, but there is a port number with IP data, because port number only exists with by default with your TCP and UDP traffic. So that is the reason ASA can't inspect the traffic by default. Okay, so it just create the entry, but it's never going to check this entry. Never going to check this entry. At that time, interface receiving the traffic, okay, it's going to check connection table. It's not going to check the connection table. Why? Because there is no default inspection for IP data. So just it's going to directly going to check routing table. So routing table tells about move to 0 by 0. So now this is the interface with no LSP. So that's why traffic is directly hand over to the global policy, and global policy is going to deny IP any. So that means if traffic is not inspected, so traffic will forward to global policy and global policy will deny it. So that's why you will not receive any reply for IP data. So what we can do in that case, if traffic is not inspected, so we need to enable policy to inspect IP data. What we need to do? We need to enable inspection for IP data also. So for that we can create policy, we can match the ICMP traffic and we can inspect it. So for that we need to create policy. That is the actual option, but there is also one option in that we can configure here policy directly, or I can configure ACL. If I configure the ACL, they are not going to look up for SLP or something. They will just check the ACL according to permission, forward the data. Okay, but this is critical. This is not good if you create some ACL which allow IP to IP from 12.1 to 10.1. So there can be some security breach in network, right? So we will see in next class how TCP UDP inspect the traffic and how we can inspect normal IP traffic also. If this is clear, we can keep this in practical. Guys,
Yes.
is there any doubt in this lecture? I think this is clear to everyone. Kanel, Nandita, Siva, Sankar.
Yes.
Yes.
Yep.
Yes,
Yep.
sir.
Yep.
Okay. Yes, Nandita. Are you asking something?
No, no, I'm telling I'm okay with it.
Okay. Okay. So I will share software information with all of you. Okay. So you can easily install and some instruction will be there that help you. If still you have any issue, I will check in the session. Okay. If you have any installation issue.
Okay.
Okay.
Okay, guys. Thank you. Have a
Yeah.
good
Thank
night.
you. Bye.
Thanks,
Bye.
sir. Good night.